extrema mean? Minimum or maximum? Extreme values. What is the difference between a local maxima and a global maxima? And just so you know that there are some synonyms there. Sometimes you'll see the word local, sometimes you'll see the word relative, thank you. And then sometimes you'll see the word global, and sometimes you'll see the word absolute. So those two things are synonyms. So what is a local or relative maximum? Okay, not technically the maximum of the whole graph, but it looks like a maximum. Can anyone elaborate on that?
When a graph extends to either infinity, it's the highest point that we can measure.
Okay, so the absolute is the highest point on the graph. Got that. What's a local again? Okay, so if you are the highest point in a certain area, then you are a local maximum. An example of that would be the richest guy in Greenwood, whoever that is. He is a local maximum. He has the most money in Greenwood. So he has a little bit of local fame probably, right? Locally, he's a maximum. He's obviously not the global maximum. I think that's a guy in Mexico right now. I think oil, gas. Anyway, some guy in Mexico is the richest person in the world. And so he is he also a local maximum? Yeah, he's the richest guy in his town, but he's also the highest point in the whole graph. So that's kind of the difference between a global maximum and a local maximum. What are the global maxima and minima of that graph up there? So what's the maximum? Where does the maximum occur? Train yourself to write it that way. Half the time they ask for the maximum value, and half the time they ask for where the maximum value occurs. If you answer it this way, you've answered both questions, and they know exactly what you're talking about. And it reminds you constantly that the y value is the maximum, and the x value is where that occurs at. So what about the minimum? Minimum value is 0 at x equals 0. When is the derivative positive? When is the derivative negative? And when is the derivative 0? So start with positive. Good. And what do you always use when you're deciding that? What kind of values do you use to tell where something happens on a graph? Always x values. So from 0 to 2, when is it negative? And when is it 0? So the derivative is positive from 0 to 2, negative from 2 to 5, and it equals 0 at 2. How do you know it equals 0 at 2? What are you looking at when you're looking at the derivative? Remember that derivative is the slope and point, right? So it's positive, positive, positive. Oh, go to a horizontal tangent line. 0, negative, negative, negative. Does that make sense? When is the graph increasing? When is it decreasing? Have we learned something there? If the derivative is positive, the function is increasing. If the derivative is negative, the function is decreasing. And if the derivative is 0, there's possibly a local maximum. So we've learned some things about what a derivative can tell us. It's going to be really important in our future. You don't have to draw this whole picture. It's kind of a summary of what we just learned. You can have absolute and local minimums. This is both an absolute and a local minimum. This is a local maximum, local minimum, absolute max, local min. So you can kind of see how those are labeled. Really quick mental note. Is the derivative 0 at all of the local maxes and mins? What's the derivative here? What's the derivative at a sharp corner? Does not exist. So a local maximum could have a derivative of 0, could have a derivative of undefined. And then, of course, endpoints. The derivatives don't exist at the endpoints because there's no left-hand side. Same picture, kind of, still don't necessarily have to draw it. Critical points are the name that we're going to give potential local extrema. They could be global, but mainly we're going to focus on those as local. Extrema can only happen in two places, either what we're going to call critical points or at the endpoints of the graph where the graph ends. We saw that on the last picture. As you saw in the bell ringer, there is a very strong connection between the derivative and the extrema. Now, if you look at this place right here, the derivative 0, would you call that a maximum? No, it keeps going up. So we'll have to figure out how to identify what is a critical point, what's a maximum, and what's a minimum. This summary is what you really need to write down. The picture is great, but the summary gets you a good. So, summary. Critical point is a place where the first derivative equals 0 or is undefined. Those can be maximums, they can be minimums, or they can be a word that I'm going to call fakes. Don't ever use that word on an AP exam. It's not a real math word. But it's just a place where it might have been a maximum, but it's not one. So we're going to call that a fake. But don't use that word on the AP exam. A local maximum is a place where the derivative is either 0 or undefined, and the derivative changes from positive to negative. Would you agree that would create a maximum? If the derivative changes from positive to negative, and it's 0 or undefined in between, we go from increasing to decreasing. Wouldn't that switch cause a maximum? A local minimum happens when the derivative is either 0 or undefined, and the first derivative changes from negative to positive, decreasing to increasing, which will cause a local minimum. An absolute maximum or an absolute minimum, we will look at the local maxes and local mins, and we'll look at the endpoints, and it's going to be very non-scientific. I don't know. We're just going to plug them all in and see which one's the biggest. We're going to do what's called a candidates test. We're going to take all the local maxes and the endpoints and all the local mins and the endpoints and plug those in and see which one gives us the biggest y value and which one gives us the smallest y value. And those will give us absolute maxes and absolute mins. This is a 2-day lesson. Today we're going to focus mostly on local maxes and mins. Tomorrow we will focus on absolute maxes and mins. But this is a summary of what we're learning over the next 2 days. While y'all are writing, does anyone want me to send around a Pi Day sign up? I will. If you happen to sign up for forks, you need to bring those the day before. If you don't want to sign up yet, you can wait until tomorrow. I'll just pass them out while we're. Is everyone finished writing? Okay, so let's look at this example. Given the graph of f of x, find the following. Where is the derivative equal to 0? And we are going to have to estimate because we are given numbers. So where is the derivative equal to 0? Somewhere in here? Maybe negative.
It's around negative.
I'm going to call it, yeah, okay, negative 2 point back, I think. Yeah, because I've got my line. Somewhere. 2.8, maybe.
Yeah.
On what intervals is the function increasing? Is that the only place, by the way?
No, it's around 3/4.
3/4. My calibration might be off. And 2. I would have to be very lenient on those answers, right? But we're looking at where the graph turns around. On what intervals is f of x increasing? Now, this does have to do with what I answered in part A. So where is f of x increasing?
And then from 0.75 to
Any questions about that? Good? Good. And when is f prime positive? Copy paste, right? Increasing and the derivative being positive is the same question. So what we're learning is that a function is increasing when the derivative is positive. What intervals is the function decreasing? It's always x. And then again, copy paste. Any questions about that one? Okay, which brings us to a thing called the first derivative test. You don't have to write everything down, but this is kind of the gist of the first derivative test. Let C be a critical number. We've already defined what is a critical number. Could be, and when does a critical number happen? When the derivative is 0 or does not exist. So we have a point C, an x value C, where the derivative is either 0 or does not exist. We have a continuous function. It is important that the function be continuous for the first derivative test to work. If the first derivative, and you've already written this down, right, in our summary. Remember, the summary was all the stuff we were going to learn today. If f prime changes from negative to positive at C, then f has a relative minimum at that point, C, f of C. If f prime changes from positive to negative at C, then f has a relative maximum at that point. If f prime is positive on both sides or negative on both sides, and otherwise doesn't change signs at that point, then you have neither a relative max nor a relative min. You have a fake. A place that happens at is on x cubed. Is there a maximum on the graph x cubed or a minimum on x cubed? It just kind of has that little stall point. Well, the derivative of x cubed, 3x squared, is 0 at 0. But it increases on both sides. So it is neither a maximum nor a minimum. Later in your calculus career, you will be doing justifications. Not too much later, we're getting close. Where you, on an open response question, justify why something is the way it is. And a lot of times people will try to refer to the first derivative test as why a function is increasing or decreasing. The first derivative test does not tell you whether a function is increasing or decreasing. It tells you whether a critical point is a maximum or minimum. So just mental note, the first derivative test tests for maxes and mins to see if a critical point is a maximum or if a critical point is a minimum. The first derivative test tests to see if a critical point is a maximum or if a critical point is a minimum. Our first example. Use the first derivative test to determine if a critical point is a maximum, a minimum, or neither. If you were on an AP exam, instead of using the word fake, you would use the word neither. So find all of the extrema of this function. Now, notice there are no endpoints given. Tomorrow we'll talk about what to do when there are endpoints given, and we'll have to check those as well. For today, we were talking about relative or local extrema. So, if I want to find the extrema, what's the first thing I need to identify? The critical points. Where are the critical points? So, the first thing I'm going to do is find the derivative. So, find it. What is the derivative of x cubed minus 3x? Okay, and I want to know when that's 0 or undefined. It's never undefined, would you agree? The denominator never equals 0, there is no denominator. So I want to know when this equals 0. Now I'm going to try to figure out whether those are a maximum, a minimum, or a fake. So what I'm going to do is I'm going to make what's called a sign chart. Now, luckily you had me or Miss Loafer Algebra 2, and I've made you draw one of these before, so this will look pretty familiar. I'm going to find out whether the derivative is positive, negative on each side of those critical points. So, I'm going to pick a number to the left of -1, and I'm going to plug that into the derivative. So what's a number to the left of -1? -2. And if I plug -2 into the derivative, do I get a positive number or a negative number? I get a positive number. What if I plug in something like 0 into the derivative? And what if I plug in something bigger than 1? So, now you don't have to draw this top part. If the first derivative is positive, what does that mean for the function? And if the first derivative is negative, what does that mean for the function? And if the first derivative is positive? So what would that make -1? A maximum, right? If I'm increasing and then decreasing, then x equals -1 is a maximum value. And what would that make 1? A minimum. If my function is decreasing and increasing.
Students, please pardon the interruption. I need to see the following students in the high school office at this time. Alexa Votoff, Jay Carroll, Story Whitson, Macy Webb, Colton Hughes, Tanner Chap.
So my critical points are x equals 1 and x equals -1. Now I need to decide if we have a maximum or minimum. Now, if it just wants to know if it's a maximum or minimum, you could just say a maximum at 1 or -1, minimum at 1, -1, whatever we want to say there. If they want the maximum value, what do I need to do? Plug it into the original and find y. I'm going to go ahead and do that. Probably wouldn't have had to on this problem by the wording, but if I plug in 1 into the original, I get 1 cubed minus 3, which is -2, plus 2, which is 0. So I have a, where did I plug in? Positive 1. Minimum of 0 at 1. And a maximum of, if I plug in -1, I get 4. And I found that out by the first derivative test. Now, one thing you need to know about justification, this one didn't ask me to justify, so I didn't have to. The AP exam will not grade a sign chart for justification. So if it did say justify, you would have to say at x equals 1, f prime changes from negative to positive, and at x equals -1, f prime changes from positive to negative. You would just have to put what you put on your sign chart in words. The sign chart is still beneficial for the work purposes, but it's not good enough for justification. Any questions about how to apply the first derivative test? Now, just to remind you of the gravity of what you've just done, you just found the maximums and minimums on a cubic. You could probably graph this now, right? You've never been able to do that before. You've never been able to take a cubic function in standard form and graph the maximum and minimum values. So we just learned a lot without picking up a calculator. It's pretty impressive. Try the next one. Next one asks a lot of questions. A lot of questions packed into one. finished, but what's the first thing you've done? Find the derivative. We want to find critical points, maxes and mins. The first thing we're going to do is find the derivative. And then what are we going to do with that derivative? Set it equal to 0. Is this one factorable? Is anything easy factor out of it before I even start? So x is 3 and negative 1. And those are my critical values. I don't know yet whether they are maxes, mins, neither. I don't know. But I know that those are, if there's a relative maximum, it's one of those. The next thing I'm going to do is make a sign chart. So you can see why I made you do inequalities, solve inequalities the way I made you solve inequalities. It really led into this great. When I'm less than negative 1, the derivative is now if I plug in negative 2, I get negative 5 times another negative. 2 negatives make a derivative. And here's how I'm noting that on my chart. So you notice I have this is values on f prime. Between negative 1 and 3, 0 is an easy one. Negative times a positive is a negative. And after 3, positive is a positive. So my function f, if you don't have to draw this part. This is the whole sign chart is just for you. Nobody's going to grade this sign chart. AP won't grade a sign chart. But it's so helpful to kind of get a picture of what the graph is doing. It is increasing and then decreasing and then increasing. So let's go read what the question asked. It says find all the extrema. Okay. When it's worded that way, you could answer that a lot of ways. You could probably put it in a point form. But again, if you have an option, I'm always going to answer that by saying the maximum value is this at this x value. It keeps you from messing up later down the road. And also find intervals of increasing and decreasing. I'm actually going to go ahead and do intervals of increasing and decreasing first because there they are, right? My sign chart has those on it. You can see why people get the first derivative test and testing for increasing and decreasing a little mixed up because they're very much related. So we are increasing from negative infinity to negative 1 and from 3 to infinity. And we are decreasing from negative 1 to 3. Have a relative maximum at negative 1, and I have a relative minimum at 3. Where do I go to find the actual value of those maximums and minimums? Back to the original. I actually want the y value. If you were to accidentally plug them in the derivative, what are you going to get? 0, because they're critical points, right? So if you accidentally do that and get 0, kind of caution yourself on that. So if I plug negative 1 into the original, negative 1 cubed is negative 1, minus 3, because negative 1 squared is positive 1. So negative 4 plus 9 is 5, 6. Notice I am doing this without a calculator. You don't have to do it all in your head, but this would probably be a non-calculator question. And that was the maximum. Minimum at 3. 3 cubed is 8. 3 squared is 9. 9 times 3 is 27. 8 minus 27 is negative 19.
Did you just say 3 cubed is 8?
Oh, uh-oh. 3 cubed is 27. That makes it easier, doesn't it? Because then it's 27 minus 27, which is 0. Minus 27 again. Negative 27 plus 1 is negative 26. I'm glad Katie was paying attention. I can pretend I was trying to test you. I just did that. Any questions? Yes. Good question. Let me go back on it. Yes, negative 27 plus 1. You are. Negative 26 is the relative. I'm going to skip the first one just because I feel like it's almost not worth our time. It's too easy. But I am going to go ahead and do the second one. Just find the critical numbers, find the intervals of increasing and decreasing, and apply the first derivative test to identify relative extrema. I'm going to do both. Do what?
What are we doing with these?
Find the critical points, intervals of increasing and decreasing. Same thing we just did. And identify maximum. So I have x plus 2 to the 2/3. So the derivative is 2/3 x plus 2 to the negative 1/3 times 1. We do need to think about the chain rule. There's actually nothing that happens there, but we need to think about it. I'm going to set that equal to 0 or find out when it's undefined. It would be nice for me to know what does it mean to raise something to a 1/3 power. So this is a cube root of x plus 2 on the bottom. So actually this derivative does not equal 0, because 2 doesn't equal 0, but is it undefined? Where is it undefined at? Negative 2. Everyone agree? Negative 2 plus 2 is 0. So I set the bottom equal to 0 to find out when it's undefined. So I have a critical point. At negative 2. Mental note, cube roots can have negatives in them. Square roots of a problem. I'm going to draw a sign chart. What's the only number that goes on my sign chart? Occasionally, there are no numbers that go on the sign chart. A function may possibly be always increasing or always decreasing. So if you come to one where there are no critical points, that's okay. Just means that function is either always increasing or always decreasing. Negative 2 goes on my sign chart. I'm going to pick a number to the left of negative 2. Why?
Negative 3.
Negative 3. Negative 3 plus 2 is a negative value. So negative on that side, positive on this side. So my function is good. It's a relative minimum. It's decreasing and then increasing. I have a relative minimum. It is some kind of undefined derivative value. So probably some kind of sharp corner. I know a lot about this graph. Did you know anything about it when it looks like this? Really quick, just for fun, graph it in your calculator. Graph x plus 2 to the 2/3 power. I have a relative minimum of 0 at -2, or a relative minimum at the point -2, 0. How does that question work? What's it look like? That. So we were able to identify that relative minimum, the increasing and decreasing. We even knew that those met at a sharp corner. So we knew a lot about this function based on our analysis from the first derivative. So we're learning what the first derivative can tell us about a function. That's what we're going to be working on this next couple weeks, is what a first derivative can tell us about a function. This is all week's homework. Page 198, 20 through 30 even. That is due tomorrow. It's 10, it's not even, it's 5 problems, critical points, first derivative tests. Just some basics. The packet and page 198 are due on Friday. So we will grade a little bit on Friday. What that does mean is you have no homework over spring break. So a little bit of homework now, none on spring break. Fair trade. So we're going to be looking at what the first derivative test can tell us about a function. After spring break, when we come back, we'll still be working on that, but we will then start to also get into why would you care? What can you do with this in real life? There are a lot of things that derivatives are important for. So we are heading toward that. Right now we're looking at curve sketching and maxes and mins, which you can envision how maxes and mins could help you in real life. But you'll get to see a lot of examples. Any questions about today? If you start working on the packet, you come to a question that asks a question about absolute extrema, save it. We haven't talked about that. You can answer a lot of the questions about increasing and decreasing relative maximum. Thursday, we'll be finishing this up. It may even just be part of the first, depending on how much we get through tomorrow. Essentially, you saw those 2 slides. We've got to do those 2 slides, and we've got to do these slides. On Friday, we'll do the grading. Unless y'all decide you want to do it on Thursday, you'll probably want to exercise. We could have pushed and got a lot more